For this video, we're going to be discussing system of equation word problems. So throughout this unit, we've been discussing how to solve a system of equations. And now we're going to be using that knowledge, and we're going to apply it to some real-world problems. So here's how we're going to do this. Our procedure is pretty simple. Our first step is just to define our variables. So we're going to look at our problem and say, okay, what does x mean? What does y mean? What sort of real-world things do they stand for? Second step is going to be to write two equations that model the situation. We're always going to be writing two equations, and we're going to be able to find the information we need on how to write those two equations from whatever word problem we're working with. And then we're going to solve the system. We're going to use whatever way we want to use to solve it. We've discussed multiple methods, and we're just going to pick one to use. So we're just going to go through quite a few examples of these. So example 1 says a movie theater sells adult tickets and children's tickets. Adult tickets cost $12 and children's tickets cost $8. At one showing yesterday, the movie theater sold 450 tickets totaling $4,800. How many of each type of ticket did the theater sell? So our first thing we need to do is we need to define our variables. We need to say, okay, what is x, what is y? In this case, I'm going to use the variables a and c instead of x and y. And it should be pretty obvious, all right? It says how many of each type of ticket did the theater sell? So I'm going to say A is adult tickets and C is children's tickets. I could say X and Y, but I'm choosing to use A and C in this one. So now we need to write two equations. So let's think about this. We have adult tickets costing $12, children's tickets costing $8. And it says at one showing yesterday, the movie theater sold 450 tickets totaling $4,800. So I'm going to write two equations. I'm going to write one equation that is going to be all about the number of tickets, and I'm going to write another equation that's about the amount of money the theater made. So if I think about the amount of tickets, it says there are 450, and that's made up of adult tickets and children tickets. So I can say that A plus C equals 450, because the number of adult tickets plus the number of children's tickets gives me the total number of tickets, which is 450. All right. Now that's my equation for the number of tickets. Now I need to write an equation for the amount of money. Well, if we think about it, it says adult tickets cost $12. So the amount of money that the theater is going to make off an adult ticket is going to be equal to 12 times A. Because A is the number of adult tickets, 12 is the amount of money they get from each adult ticket, so 12A tells me how much money they make off of adult tickets. They sell one adult ticket, they make $12. They sell 10 adult tickets, they make $120. Similarly, the amount of money they make off of children's tickets is going to be equal to 8C. And if I add those together, I get the total amount of money the theater makes, which is $4,800. So now I have my two equations right here. A plus C equals 450, and 12A plus 8C equals 4,800. So what I need to do now is I need to solve this system. I'm going to solve it using elimination. Now I notice here that there are no coefficients that are the same in both equations, so I'm going to have to do some multiplying. So what I'm going to do is I'm going to multiply this entire top equation by 12 so that my coefficient of A will be the same in both equations. So if I multiply by 12, I get 12A plus 12C equals 5,400. Just distributed out my 12. Now I can use elimination to solve these. I've got 12A plus 12C equals 5,400, and 12A plus 8C equals 4,800. My coefficients of A are the same, and sides are the same, so I'm going to subtract these. When I subtract, 12A minus 12A is 0. They cancel out. 12C minus 8C is 4C. And 5,400 minus 4,800 is 600. So I know 4 times the number of children's tickets equals 600. So C equals 450. So we know the movie theater sold 450 children's tickets. So now I need to figure out how many adult tickets did they sell. Well, if I go back to my original equations, I know that the number of adults plus the number of children equals 450. I know the number of children is 150. Subtract 150 from both sides, and I get A equals 300. So right now we're saying that the movie theater sold 300 adult tickets and 150 children's tickets. Now we know that we need to check this by plugging both of these values into my other equation. So I know 12A plus 8C equals 4,800. Plug in A is 300, C is 150. 12 times 300 is 3,600. 8 times 150 is 1,200. Add these together and I get 4,800. So it works. So my answer ends up being that the movie theater sold 300 adult tickets and 150 children's tickets. All right, so the key thing with a word problem is defining your variables and writing your system. From there, we just solve it like we would solve any other system of equations. All right, so let's look at another example. It says Kiana and Jamal have jobs, and the amount of money Kiana makes in 2 hours is the same amount of money that Jamal makes in 3 hours. The difference between how much they get paid per hour is $6. How much do they each make per hour? So let's go ahead and define our variables. So the question says, how much do they each make per hour? So I'm going to say X is the amount of money Kiana makes per hour, and Y is the amount of money Jamal makes per hour. All right, hopefully that makes sense to everybody. That since it's asking us how much they make per hour, I'm going to say, well, here's how much one person makes per hour, here's how much the other. Now let's write our equations. It says the amount of money that Kiana makes in 2 hours is the same amount as the amount of money that Jamal makes in 3 hours. If we think about that, that comes up with the equation 2x equals 3y. 2 hours times whatever Kiana makes per hour equals 3 hours times the amount of money that Jamal makes per hour. So we get 2x equals 3y. Then it says the difference between how much they get paid per hour is $6. Difference tells us we're subtracting. So that equation is just x minus y equals 6. So here are our two equations. 2x equals 3y and x minus y equals 6. Now to be able to solve these, we want to put them both in standard form. X minus y equals 6 is already in standard form. 2x minus y, well, to put that into standard form, put that in standard form, all I've got to do is subtract 3y on both sides. All right, 2x minus 3y equals 0. It's the same thing as 2x minus equals 3y. And now, if I take a look, I've got x minus y equals 6. I'm going to multiply this bottom equation by 3 so that my coefficients of y will match up. If I multiply it by 3, I get 3x minus 3y equals 18. All right, all I did is I took this equation, multiplied it by 3, so now my y coefficients match up. All right, I'm going to use elimination to solve this. They're the same sign, so I'm subtracting. 3x minus 2x is just x. 3y minus negative 3y minus negative 3y is 0. They cancel. 18 minus 0 is 18, so I get x equals 18. If we think about what this means in terms of the problem, it says x is the amount of money Kiana makes per hour, so Kiana makes $18 per hour. All right, now we need to figure out what Jamal makes per hour. Well, we know 2x equals 3y, so 2 times 18, oh, this should say, not 2y, this should say 3y. All right, we know 2 times 18 equals 3y. So then 2 times 18, that's 36. 36 is 3y. Divide both sides by 3, and I get y equals 12. So Jamal makes $12 per hour. Now we need to test this. And the way we test this is simply by plugging both of these values into my second equation, x minus y equals 6. We do 18 minus 12. 18 minus 12 is 6, so it works. So my answer ends up being Kiana makes $18 per hour, and Jamal makes $12 per hour. Once again, the key was defining our variables, setting up our equations, and then we just solve. Example 3 says the sum of two numbers is 17. The difference between twice the larger number and the smaller number is 28. What are the two numbers? So, if we're going to do that, well, let's figure this out. If I define x and y, I'm going to say x is my larger number and y is my smaller number. All right, it doesn't really matter. I could say the opposite of that, but it's fine. We're going to say x is the larger number and y is the smaller number. It says the sum of the two numbers is 17. Well, sum means adding, so I can just say x plus y equals 17. And the difference between twice the larger number and the smaller number is 28. Twice the larger number, that's 2 times x. Difference tells me I'm subtracting, so I get 2x minus y equals 28. Now I have my two equations right here. Notice that y has the same coefficient in both, so I don't have to do any sort of multiplying. I can just jump right to eliminating. They have different signs, so different signs means that I'm going to add these two equations together. X plus 2x equals 3x, y minus y equals 0, 17 plus 28 is 45. Divide both sides by 3 and I get x equals 15. So my bigger number is 15. Now I need to figure out the smaller number. Well, I know x plus y equals 17, so 15 plus y equals 17, so y equals 2. So my bigger number is 15, my smaller number is 2. Let's check our work by plugging into the second equation. 2x minus y equals 28. Plug in 15 for x and 2 for y. 2 times 15 is 30. 30 minus 2 is 28. So our answer is simply 15 and 2. 15 is the larger number, 2 is the smaller number. Alright, so now you know how to solve a word problem using systems. So your try it problem says, King's Dominion sells adult tickets and children's tickets. On Saturday, they sold 250 adult tickets and 400 child tickets, for a total of $22,000. On Sunday, they sold 300 adult tickets and 800 child tickets, for a total of $36,000. How much do adult and children tickets each cost? So you need to set up a system and solve it for this problem.